Through the Noise with your host, Ernesto Glucksmann.
Rob, thank you for joining me on the show. Rob Writz, you are the Director of Commercial Partnerships. You had a couple of director positions there at AMP Robotics. Thank you for swinging by and giving us a peek into this really interesting world that I just happened to come across. So I thought maybe we could just kind of start a little bit just to contextualize what AMP Robotics does and can you give us a sense of the product and the company?
Sure, Ernesto, thanks for having me. I've had a few different titles at the company over time. It's because I've been involved in the company since some of its early formative stages, when it was very small, much smaller business, and it's grown significantly. So I do have one title now for the moment at the company, and we'll see how that changes over time. But give you a quick overview of AMP Robotics. AMP Robotics was founded in 2014, and it was founded by Dr. Matanya Horowitz. And he had recently, at that point in time, come out of Caltech with a focus on machine learning, control systems, and robotics. And he had some exposure to the recycling industry. And he saw a lot of the challenges, which I'm sure we'll speak about a bit more, in the sorting aspect of post-consumer material or post-consumer waste. And really saw an application for some of the areas he was focused in, particularly in machine learning as it applies to the visual interpretation of objects and how that could help to reduce the costs of the sortation of these post-consumer materials, which is one of the major barriers to making recycling more profitable and more scalable. And so he founded the company in 2014. The operations really started in 2015 under support from the National Science Foundation. And then I was able to join the company in 2016 as we were beginning to put our first robots into recycling facilities that was using this vision-based software that can interpret these recycling materials and help sort them. Since that time, the company's grown significantly. And we've deployed quite a bit of robotic sortation systems into recycling facilities as well. But this is certainly some of the details we'll probably dive into what is that technology, how did you grow it, how do you relate that to a company, and then scale that into the marketplace.
I wanted just to kind of, for people, most of the people that listen to my show are actually, they're just podcast consumers. The YouTube channel is still getting its feet under it. So kind of describing this machine, like the videos I had seen, if you can picture a conveyor belt that goes under a big box, and in that box, there's these like pneumatic air sucking prongs that dip down and pick up something that it recognizes with the computer vision technology, right? So sort of picture all kinds of crushed things that are different shapes, and the computer's got to be able to sort out, okay, that's a milk carton we're aiming for. That's the plastic yogurt cup that's dropped into the recycling a lot, and it's got to do it really fast. It's quite an impressive machine when I see it. How did I do, Rob?
Yeah, that's perfect. I think we can wrap it up here, and you summarize it great. I think a good place to actually start is just really understanding where this material is coming from, and then quickly what it's intended to do with it, and that helps drive the use case of the technology. But we start with you and I putting our recycling into a recycle bin, right? What we call here in the United States single stream recycling. And that collection is different all around the world. They do it differently in Europe. They do it differently in Japan. But here in the United States, we primarily have single stream recycling. So we put our aluminum cans, our plastic bottles, our cardboard, our paper, et cetera, into that bin. And then it goes to a material recovery facility, which I'll probably call a MRF, in this podcast with its acronym. And those MRFs are our customers. And they are then charged with sorting out a municipality's recycle stream into various commodities that the MRF can then sell on the scrap markets. So they want to get the certain types of paper together, cardboard in one place, aluminum cans together, and a variety of plastics sorted out because there are markets that want that scrap material. And will be interesting discussion is as much as recycling is viewed as an environmental activity, it's also a very important part of several supply chains as well for material. But their challenge is, as you said, this material's coming through these facilities on these conveyor belts where it's been dumped out and tumbled a bit to get and spread out to separate the papers and the containers that are there. And it's passing through these conveyor belts quite rapidly. They can move from 100, 150 feet per minute to up to 400 feet per minute. So they're actually quite rapid conveyor systems with a variety of sorting going on, people, as well as some physical sortation and optical sorting. And our robots go into these facilities. We install them into sorting stations, what they call sorting stations, where a person may be who might be manually sorting out or quality controlling material. And generally, the recycling facilities or these MRFs tend to be about 10 to 30 years old. And so they do involve quite a bit of manual labor in their sorting. That may be, as I said, for quality control or to create a desired scrap product. But that's a really challenging activity to ask a person to do and to sustain, particularly just over one shift. It's very dangerous activity to be sorting out material that has a high percentage of garbage and potentially dangerous materials in there. We wish it was all recycling materials that made it that way, but there is some percentage of garbage and therefore dangerous objects that make it in there. These facilities are open to the outside, so they can be extremely hot in the summer, very cold in the winter, and then you're standing there sorting out this material for 8 hours a day. It's a very challenging activity, so our customers often have staffing issues. They have a hard time recruiting people, and they have a very hard time maintaining those sorting stations. Therefore, they have an operational challenge of throughput and quality to the scrap products that they produce. And so these robots that we develop take the software that we've also developed, and we integrate all of this into a hardware solution that we deploy into those facilities. And AMP Robotics is both a developer of the software, the artificial intelligence that perceives this material, and we are the integrator of the hardware. So we don't actually make the robots, but we acquire those from robot providers, and we have designed our own hardware system that holds the robot, picks the material with our gripper, and places it into these bins. And I will dive deeper in just a moment into the software itself. But Ernesto, I wanted to hold there to see if you had any questions about that, kind of setting the stage for, this material's coming in. There's a labor challenge for our customers and a quality challenge. And they are ideally producing these bales of scrap that are sold on the aluminum, paper, and plastic markets.
I mean, I have 1,000 questions, Rob. This is fascinating to me, but I can see just you describing it. This is hard manual labor. It's very repetitive. You're putting your hands into things that have sharps. Of course, they're wearing probably personal protective equipment, gloves, thick gloves, but you're still it's still moving pretty fast. It's still variety. And, I'm constantly pulling out. I'm going to call out my wife, but she puts in a lot more stuff that's in our blue bin that's not supposed to be there. So I'm doing the pre-sort, taking the stuff out. It's just very common. You're in a home or whatever. You just don't even think about it. You think, oh, it's plastic. It should go in there, right? But this is a huge challenge, is what I'm getting at, to actually get the right material out of a certain type to actually have a marketplace that can then convert that material, the sorting has to be like on point, and it evolves, right? It evolves with new products, new materials that find their way into recycling areas, right? Let's go into the actual technology a bit, because I'm just curious to know, since you do a lot of the machine learning component, what's that process like with you guys?
Sure. Yeah. And I think you had some really good points there that I'd like to just reinforce real quick. When these material recovery facilities are really designed to sort out 5 to 10 materials, because those are very strong markets. But the packaging is quite diverse and complex that we're putting into the recycling stream. And particularly in plastics, it's challenging to handle more than 30% of that plastic that goes into there. And so that's the root of some of this complexity. It's not only is it crushed and smashed by the time it gets there, but it's also evolving quickly. So, right, we had 30 years of changes to newsprint, right? Fairly slow, that we're not reading a newspaper as much anymore. We see a decrease in newsprint in the recycling stream. In 2017 and 18, China, which was the recipients of over a third of the world's recycling or post-consumer recycled material, put in strict import restrictions and bans on some of those materials, effectively removing about a third of the global market. And then in COVID, all of a sudden we went into shelter in place, and within weeks, the recycling stream changed. In that case, when you change to a more residential based versus commercial from businesses stream, you tend to get more contamination in there. And so that was the transformation this industry is undergoing, is slowly over several decades to then some rapid changes over several years to a matter of weeks. And so it's hard for the infrastructure to adapt, particularly if it's dated. And that's where the software comes in particular, because what we're using is a technology in the software that can adapt to these types of changes into what we call the evolving ton of material. So if you look at 1 ton of recycle or input material to a facility, it is evolving quite rapidly, as I just noted. And so what we're applying here is an artificial neural network, or a software that's really designed to process information in a manner similar to the human brain. And this artificial neural network has connected processing units that receive inputs from a video camera that's based over that conveyor belt, looking at those objects as they pass by, as we talked about earlier, and that's the facility's infrastructure. And then based on an internal weighting system, it has been taught and continues to teach itself about the information that's presented to really produce this output that characterizes an object. Says this is a number 1 plastic, or it's an aluminum can, or it's a number 2 plastic, et cetera. It also describes its location and its some other material attributes. And then this process really establishes a high-dimensional set of features, which we use to train this brain, or this artificial neural network, to recognize patterns in these objects. And so we use a supervised training method where the artificial neural network, or brain, compares its actual output to a desired output. And from that, we generate a learning algorithm that adjusts the weight of the network's connections until the actual and desired outcome produces the lowest possible error rate. So we continue to iterate on that process, right? We acquire data through our video cameras. We then develop and have developed software to capture that imagery, to train the neural network to continue to present it with imagery so it can test itself and say, I've done these well. These objects I'm not confident in. And then we could go and find examples of those lower confidence objects, obtain imagery of those, and give them a positive label, put them back into our neural network training, and train this brain that now at this point we're able to deploy into any single stream recycling facility at a very high accuracy of identification. It's reached a point where it's been exposed to so much imagery and confident imagery that it's able to identify these core commodities and sort them with the robot. So we have both this real-time inference that this brain is applying, but we also have this whole infrastructure to acquire examples, continue to train and improve the brain, and then actually deploy little little pieces of the brain out into the robot fleet where they actually perform the identification in real time. All of that training we do in the cloud, all of the identification is done on the edge because it has to happen really fast with a computer at the point of the recycling facility and the robots. So in essence, it's in some ways similar to how an animal brain functions or a human brain, and how we've learned, particularly when we were young, 1, 2, 3, I'm sure Ernesto with your son, think of some, here's when we were doing some positive reinforcement, right, with the child, when you're like, this is green, this is blue, this is round, this is up, this is down, right? And then correcting those with your child. It's actually a similar process. We're just providing positive reinforcement for areas where we've seen that the confidence is low in its identification of an object. And the reason why it's important to have a high confidence is because it's really twofold. One is you want to sort the right objects, whether it's to create a scrap bale or quality control that goes into a process. The other is that we ultimately want to report on what's happening here. We are effectively digitizing this material and waste stream, and we want to be able to extract information about it. And so you need to have a fairly high level of accuracy in order to describe in high volumes potentially the recycle and someday the waste output of a municipality or a city, county, or a region.
Do you see like ancillary services from you guys, like maybe since you have this neural network and, I'm not ready to maybe as a municipality buy the machine itself, but I would like to know what's happening in my stream for statistics, for analytics. Could I get a camera and contract you guys to do just kind of doing an analysis of what I'm getting, what's coming through?
Yeah, that's certainly a point of demand we're seeing from municipalities in particular. They perform these what we call waste characterization studies fairly consistently to understand what the output of the waste and recycling stream are. Most of the recycling facilities in the United States are privately run under a contract with those municipalities. So there is a bit of a firewall there in terms of their private operations and the information that's happening there in terms of their recovery. But their contracts with the city often require them to do a certain amount of auditing each year. And it's actually quite labor intensive and quite complicated. So we recently just released a product where we took the eyes or the video camera and the brain, this artificial neural network software, out of the robot sorting system and package that together to just put that in different locations through the recycling facility where we can really understand the composition of the material as it's passing through from the entry point to the exit points. And we're scaling that product now. A lot of our focus is on describing the output of the facilities first. How much material might they be losing to landfill? What's valuable in there that they should potentially harvest? What's the quality of the scrap bale that they're producing for the markets, which is actually a very important thing because the recycling industry historically has not had a way to say, here's what's inside that bale of scrap. And we're working really hard on helping our customers relate to their customers to say, we're putting this type of material in there and meets your standards so we can drive confidence into the downstream markets to buy post-consumer scrap material. But we'll also be intersecting that with the municipalities and their desire to know the performance, what's coming out of their municipalities, And really, because they need to understand how to collect the material, is there contamination in there? Are there certain neighborhoods they should be targeting for an education campaign to reduce contamination? Okay. So it's actually a quite interesting and complicated supply chain happening around post-consumer content.
Whoa. Okay. So then I would presume that might actually help with then the sale process of the bigger robotic equipment, the removing of chains or what, you do the analysis in the beginning, help use the computer vision, the very same computer vision technology tools that you have to in the sorting process, you're using it as to calculating the stream. And then you can maybe, it sounds like this is the aim. You'd be able to work backwards. Okay, if I did get this machine, we have this level of confidence that we could identify this stuff out of it and sort it out. So it's worth then the cost or something for the machine investment, right? Because I would assume, how do you guys now get your equipment into one of these MRFs at the moment? Is it a big leap of faith for them to put one of these big expensive machines, into the stream? Or do they probably know, intuitively, they probably know quite a bit because they've been doing these assessments, right? But taking that leap with you guys as a new technology, what tends to be, this is the better question, what tends to be the thing that finally compels them, okay, yeah, let's contract you guys in here?
Yeah, that's a good question. So it's a bit of multifaceted answer. In one ways, it's around the maturation of the technology itself. Not only AMP, but our industry and our competitors. We are no longer in this early adopter phase where, it's a leap of faith to put this into someone's facility. We've deployed several hundred robots around North America. So we're really in that kind of classic technology adoption stage, moving from the early adopters to the early majority. And so our customers are now repeat customers. It's the majority of our customer base. And they're also not acquiring one robot, maybe letting it soak for 6 months to a year to see how it works. They're acquiring multiple robots at a time because they understand the potential it has to stabilize the throughput at those sorting stations and ensure the quality and even potentially increase the throughput because the robot operates faster than the human. But early on, there is a leap of faith aspect. And that's really often classic technology adoption, right? Who's going to do this first? Who's going to take the leap of faith on behalf of others? And we were very lucky to have, in some ways, several guardian angels for us. And first was support from the Carton Council of North America. This is a group of carton manufacturers who have gotten together over several decades to help grow the infrastructure for recycling cartons. These are things like your milk cartons, your juice cartons, soups. They're actually quite diverse, and you find them with lots of packaging. And they actually subsidized our first 3 robots, helped us put those into the field and really learn about what it took to have an effective product, transitioning from the laboratory into what is really a quite demanding application. Another guardian angel we had at that time was Brent Hildebrand, who is at GFL. They're a major integrated waste and recycling provider in North America. And we were very lucky that he was very open to this, understanding the potential and allowing us to have access to his facility to install a variety of robots to understand what would work best in those applications. And so the industry itself is an operator's world, right? It's run by these folks who are there on a daily basis, making sure their employees are safe, first and foremost, and then in trying to ensure the quality of the product and bring in a volume of material. And those operators, like you said, they can go out there. They have a pretty good sense of what's passing through their facility. but they don't necessarily have a data-driven way to report that. And that's something that we're trying to bring to the industry is the ability to really understand that stream. And if you can understand what's going out, for example, you can start communicating confidence to your customers, as I mentioned earlier, around the quality of that material. And I bring that up because in several of these scrap markets, there isn't a high sense of confidence in the quality of post-consumer content. So for example, in plastics, if you're looking to buy recycled content or recycle material that you can recycle into plastic pellets to then build that into a product with recycled content, you're most likely going to obtain that from an industrial source first, if you can, because it's the cleanest source possible. So it could be extras or outputs from an industrial process, like film creation or plastic creation where you have shavings and extras. But as soon as you move into this consumer world where people are mixing materials, which could have food waste, it could have the sharps, the other materials from the recycling facility just found their way into the other bales. You generally have a lower level of confidence, and it may not be your most desired material. But what we see are brands, particularly consumer packaged good brands, increasing their standards for post-consumer content now in their packaging. And so in order to ensure that, they have to come to this world of the material recovery facilities to acquire that plastic, that aluminum, et cetera, to meet those goals. But there's this quality gap. What's in the material? How much do we know is the right content? How compliant is it with our downstream process? This is the information we can derive from the AI in describing these materials. And it's this type of confidence that we hope to continue to drive into the market with data-driven decision-making so that these packaged goods can meet their content goals, but also really drive this confidence to want to use more and more post-consumer content, because they have to if they want to reach those types of commitments that they've made, like 25% post-consumer content by 2025. So for as much as there is the material and the will to use it, there's this kind of data gap, information gap, and quality gap in between that we think this, just simply the data can help really reduce that gap and increase the consumption of this post-consumer material.
I mean, I would imagine the guys purchasing the raw materials, plastic pellets or whatever, they're used to being very specific about what they're getting, the type of plastic, the format it's in, whatever. I don't even know what they usually would ask, but to then go into this post-consumer thing, they're going to ask, well, how do you know you have exactly that level of, how do you know is going to be the question. And so your service, your product, it's a good way to pull in that data. It's not us just saying, yeah, that's what our sorters usually pull out of the stream. It's this machine that's taking images and actually can tell you by the bale how much of it is in there and in the conditions, perhaps, right?
That's right. That's done today by our customers doing visual observations themselves of what's on the outside of a bale, but it doesn't really tell you what's truly inside of that bale. So the recycling industry has a lot of potential, but it has a lot of cost barriers, and that quality aspect is one of the larger cost barriers that's holding it back in terms of being able to be an even more profitable industry and to meet the demand that is building through those post-consumer content goals in particular.
Now, I got to ask, can you give me some comparisons with the computer vision? I mean, for a while, I used to think about AI as just being super, super narrow tool that's actually quite expensive to create these machine neural networks. I know the costs have substantially dropped there. The power of scaling computing resources is just incredible. It's Amazon, Microsoft, and probably more so Amazon eating up the world here with that stuff. But can you give us some metrics where it's surprising how well it can perform. I know that it can't be every product class. It just depends, obviously, what's happening. But I'm not even articulating this the right way. What has stood out with this technology? What have you guys been able to pull apart?
Well, one important thing to consider is that the fundamental technology that AMP Robotics is applying is similar to what you may see in autonomous vehicles and their use of visual interpretation of imagery, in agriculture, where they may be interpreting the quality of crops based on imagery of the plants. And so there actually is a huge infrastructure around these vision-based or camera-based artificial neural networks. Now, you certainly have to build a product. You have to write your own code and your own architecture to do that. But the important note there is that there is a broader intersection of several technologies that are driving advancement as well as the reduction of costs. And so we see this through computing processing, right? You need a significant amount of processing and graphic card usage on this imagery, but you have a reduction in the costs around that through other applications of AI, as well as the Bitcoin mining and gaming as well, processing through those industries as well. Folks like Apple, Google in particular, and academia frequently release architectures for artificial neural networks that you can review, understand how that might apply into your applications and adapt that as well. So we have this kind of intersection of multiple technologies that's driving down the cost, kind of similar to build up over time and the use of the internet, right? You had telecommunications, the bandwidth, and then a demand to help drive those costs down. And so what we're able to do is then package that efficiently for with our own architectures and our own data stream, because it's unique, right? We're dealing with crushed garbage objects or scrap commodity objects. But Google and others are not developing AI for garbage. They're developing it for autonomous vehicles,
people, cars, the kind of right. It seems to have a lot of libraries for identifying
That's right.
Like a human being versus a car out there, right?
So we're able to adapt this and then apply it and grow it as well. And so there's a lot of different types of materials in the stream, but our AI identifies right now up to 40 different categories and subcategories of material. In the primary commodities that we're sorting out in these facilities with the aluminum cans, the cardboard, et cetera, that have very strong markets, our AI is able to identify those at a very high level of accuracy in the high 90%.
90%.
Yeah, and it's confidence that object is what it should be.
Wow.
So it's
cardboard specifically, cardboard going through it, it's going to 90% of the time identify that that's cardboard and it's likely to be cardboard.
That's right. Yes. And that includes in the occluded objects where you may have objects stacked on top of each other, but you can see part of it. Certainly if the object is totally covered, we can't see it, but neither could a person in that point in its application. And neither could other forms of optical sorting as well. So these recycling facilities, one thing to keep in mind, I mentioned their vintage earlier. They are challenging in some ways for both the human and in automation because they're pushing a lot of material through an old infrastructure. But we're able to identify those core materials at a high level of accuracy, and then we're able to sort them at a very high level of purity into the bale. And that's, as I mentioned earlier, that's a quality question that the industry's had a challenge reporting in the past. Through the robots' recordings and metrics, we're able to understand the purity of that product, and those tend to be over 98% purity of the desired commodity. So we're able to both identify at a high accuracy and create the scrap commodities or quality control a scrap production at a high level of purity, and we're able to sustain that with the product. And that's what's missing when your labor supply is currently turning over in a matter of weeks in these facilities. Not only is it the throughput, but it's also the knowledge. This is complex material. If you and I were put there, we'd be pretty nervous on the first few weeks, because we'd have to stop and look at all of these objects, really understand what they truly are. Particularly plastics, they're quite complicated with a lot of different expressions and a lot of different potential mixtures of plastic. So that is both an establishment of confidence through the metrics, and then it's also happening at a high rate of speed. So these robots are picking from 80 to 140 picks per minute, depending on their configurations and the material flow. That's 3 to 5 times the speed of a person.
Okay,
and a person probably can't sustain that over an 8-hour shift, or they'd have a severe case of tennis elbow, or their shoulder would get worn down quite quickly with that type of movement.
Wow. So you're beating the human person in terms of duration, speed, amount, but also accuracy at this point, because it's sustaining, right? I'm sure in the morning everybody's pretty accurate. You've had your coffee, you're fresh, but after lunch you've had a big burger or whatever, you're just it's tough, late, laborious, tedious, repetitive work, right?
That's right. And you can imagine right now, like our customers in Florida, in their facilities in the summer, it's probably 110 to 120 degrees inside there all day. It's really hard to sustain that level of interest and accuracy. But also the robot is maintaining this vast ability to infer the material. And each time a person leaves and you have to bring someone new in, you're actually training them up in what is fairly specialized knowledge of recycled content. And that takes several weeks to get them up to speed. And generally, our customers tend to turn people over within several weeks. So by the time they're up to speed, they're out, and the robot maintains that, or the robot fleet broader, right? Because we have a network effect across all these robots. They're collectively sharing through our neural network training the materials that they learn about. That is maintained. And it's for the benefit of our customers to have more robots deployed. The more robots we deploy, the more data we acquire. And this more we're able to train a neural network on variances and lower confidence material, and then reshare that out to the fleet. So that having a stable knowledge of that material is actually quite important. It's a bit understated in the product. It's harder to quantify, but it's very important for our customers to know that it continues to maintain the accuracy, and the perception accuracy in particular of the evolving ton of material that I mentioned earlier.
I mean, and there's a couple of videos where it's the shape of the packaging getting crushed and at different angles and different, it can identify it with incredible precision. Just, whether it can actually get it out of the streamer. So that's probably another challenge to the whole process, but like to actually be able to know that that's happening. And I'm reminded of, like, if you ever had to rent a car and park it somewhere, you didn't pay attention where you parked it. It's hard to sometimes, like, your brain's not used to identifying. But your car, the car you use every day, you could park it in a really long row of cars, and for whatever reason, your brain seems to like see it at the corner of your eye the moment you happen to come into vision, right? That's right. To that.
It's a very visually descriptive world in this stream. There are some plastics, right, that some people may put in, like a thermoform shaped plastic that might be used as some form of packaging to hold like an electronic device or something. This can be quite bland, right, and boring looking. But outside of that, it's a very colorful and data-rich world, particularly in the world of consumer packaging. If you go and look down the aisle of your grocery store and just to look at the vast amounts of visual interpretation that's there. And the AI and the artificial neural network that we've developed is looking at those patterns. It's using a pattern recognition at a several pixel level. And it's looking at inputs such as the way these objects crinkle and crush, the way they shine under the lights that we turn on them, the brand logos, the ingredients lists, all of these different patterns it puts together to infer in real time what this is. And a really good example of that is the work we've done on both coffee cups as well as coffee pods. In terms of poly-coated coffee cups, our customer in Colorado, GFL, worked with their community to accept coffee cups into the material stream, because you could sort those with cartons. They're actually very similar, right? You have paper with a little plastic lining inside, and there's a market for those, as the Carton Council of North America helped develop, as I mentioned earlier. And our initial foray into that several years ago was say, yes, we can identify those coffee cups, and we could prove the robot can sort them, which it does, which we did, and it does in production today. We also took it one step further to say we can also identify which of those coffee cups are Starbucks cups, because it's such a distinct brand on there with the consistent ingredients list on the side with the little boxes to check on. So we're able to sort those coffee cups, but we can also report in the data how many of those are a Starbucks cup. Similarly, we worked with Keurig Dr. Pepper in their transformation of their Keurig coffee pod product from polystyrene to a much more recyclable and recoverable polypropylene. And so we developed the AI to recognize these coffee pod shapes as well. And so those can be sorted into plastic bales for those markets. And what's also powerful about that is we can also understand that flow or the composition, how many of these pods are there, and then help Keurig, Dr. Pepper, in their effort to work with communities to accept that material into the recycling stream. So there is often this question and this creation of a value stream for these new types of products. What goes first? Do you collect them? Do you sort them? Do you need a market to buy them? Some of them are quite challenging, and we work with partners like Keurig Dr. Pepper to help prove that, yeah, we can sort these, we can identify it, and if we can identify it, we can move it. And so then we collaborate with them and others, like the Recycling Partnership, who's been on your show here, to work on the collection and market mechanisms for some of those challenging plastics in particular that I mentioned earlier, where about 30% of that plastic input is currently not sortable because of its packaging complexity.
I would imagine that this is still it's an evolving process anyway, because manufacturers like to change their packaging to try to respond to better identifying their products on a shelf, or just simply new product offerings or whatever. Do you wait? Would it be better if there was some kind of like national registry? Somebody makes a product, they put the image of the product that's just put in. Is there one? I don't even know. That then you could cull through to get those images so that you're anticipating this stuff getting into your streams, or you're just sort of collecting the data with the current client base that you have, and just that's enough work right there to optimize and improve the AI.
Yeah, that's a good question. So it's a bit of both. When we work with a customer or partner, can we identify this type of material? And therefore, can we sort it? If we can identify it, like I said, we can move it, certainly. We work with them by receiving samples of their material, training the AI around that, and then taking that type of training and exposing it to the production brain, where we have access to billions of objects over time and finding representatives of those objects. So we're quite advantaged in that we can move quite rapidly to find those examples in the material stream. Challenges in there could be, is it frequent enough? Is it big enough to see? And is it there? But oftentimes those consumer packaged goods want to know, is this material in the stream? How can we plan around this? And then certainly they're also looking at, if we're going to change our packaging types, in the list of all the things packaging needs to do, right? It's actually quite a complex world. It has to protect the product. It has to keep it fresh. It's a certain type of food. And then ideally and what we're seeing more and more is its recyclability or end of life is coming up higher on the list of priorities. some products have not necessarily been designed in the first place to be recoverable, and some of them are. And we're talking to more and more companies about how can your technology identify.
Sorry, Rob,
products?
hold on one second. This is just the way it works.
Oh, no problem.
On my show, I got my 6-year-old sticking his feet up to help him with the socks.
I understand. My daughter comes in too. Hey, how are you?
He paid me off with a treat. Thanks a lot, buddy.
Awesome.
Okay, you're gonna be on the show now. Thanks. Bye.
Yeah. One thing on top of that, I want to point out, particularly around plastics, because there's a lot of tension on plastics, right? Because it's a big focus on its supply chain, how to recover them, and it's certainly of quite exposure to consumers, right? We're all seeing challenges around plastics, marine plastics, et cetera. The Association of Plastics Recyclers has a design guide and for packaging. They also have a process, which is voluntary, but a process that when designing packaging or changing packaging, a packaged good or household good can take it through that process to understand how it would be recovered in the recycling stream. So their design guide is excellent. It gives you all kinds of recommendations, not only about the base plastic, but the adhesives, the glue, the labels, the caps. All of these things are actually quite complicated and of different polymer types that can influence the downstream recovery. But they also have a process to go through to understand how it could be sorted out in a recycling facility today. It is currently based primarily on the older technologies, but as more and more robots are deployed, we will see robotic sorting, particularly vision-based sorting, going into their standards. Say, can this be sorted optically? Can it be sorted by a shape? Or can it be sorted through a vision technology as well? And so that way a packaging producer can understand in their design for recyclability, how is this object going to get sorted? Will we be able to meet goals not only of recyclability, but potentially filling our supply for recycled content as well?
At the quality that it needs to be
to
be then sold into the new market. I'm just curious to know about the neural network. Do you is there I would just imagine the package around the product packaging, the label, the telling you the ingredients or whatever, that image is his fingerprint in some ways, right, for that particular product, right? And they all try to be distinct because that's the brand for each, everybody that's competing in the yogurt cups section or whatever. But at a certain amount given that you have so many images, is there a risk that you could then introduce too many packages that could degrade the AI's ability to identify something accurately? Like if there's a package for whatever reason, or haven't come across that issue yet?
It's a good question. We haven't come across that issue, but the challenge will be how frequent is the object in the recycling stream, right? So if it's something that rarely occurs, the AI is not going to see it as much. So it's going to have a lower confidence ultimately because it hasn't been exposed to it as often. If it's something that's highly frequent, i.e. something that should be there, it's going to have a much higher confidence in its ability to infer what that object is. But if we're looking at something that's very infrequent, there's just not going to be a lot of examples of it.
So it's optimized towards the greater scale, greater quantity, the stuff that we can pull out fast, which presumably you can then create a market or have a market to recover some of that.
That's right.
Yeah.
There are, as I mentioned earlier, about those 5 to 9 core commodities, and there's probably another 5 to 10 material types that are of high frequency in the recycling stream, but don't necessarily have a market developed. People are putting them in the recycling stream, but they are slow to have a market to buy and use that material. Really good example is the plastic thermoform that you may find around your strawberries or your blueberries. That you buy.
Hard plastic box.
This is a clear plastic polyethylene, and it's very similar. It's the same polymer that you find in your soda bottle or your water bottle. But because it's a thermoform, it has that shape, right? A clamshell kind of shape. For those of you who are on the podcast, I'm doing opening like a clamshell if they're listening. That has a different viscosity index when they go to recycle it. So effectively, it creates a slightly different type of glob in the melting process. And
the goop of it,
a different type of goop in that process. And so the bottle reclaimers, who have done a great job building a value chain to obtain plastic bottles and recycle those, can only accept so much of that in their stream before it affects their process. But we know it's of high frequency in the recycling stream. So there's a lot of effort now in place to say, well, can we harvest that for other purposes? And for us, we see that quite frequently. We identify that object, but it has time still to develop its market.
And how this is probably speaking out of the zone for you, but how can a marketplace then be created to recover this particular material that could impact bottles if there's too much of it in there, right? I mean, what does that mean? Like, are they taking the is that part of the 30% that just simply like has to just get pulled out and just not used right now? It's just going to waste.
Yeah, in the case of this number one plastic thermoform, it may be being passed out of the facility. It may be being caught in the PET that's going to the bottle reclaimers and potentially overwhelming their process. There's a few ways to work on that type of market development. It depends on certainly the state of the use of that type of plastic in particular. In today's world, we have these mechanical recyclers for plastics. They take the different polymer and they melt it down, and then they make plastic pellets out of that, which could be used for other applications. Some of those are used for the same purpose, like the bottle-to-bottle recycling, but most of those actually go to a downgraded step because it's hard to melt plastic and bring it back to its original purpose. There's an emerging market called molecular recycling or chemical recycling, where they're actually taking that plastic material down to its monomer level and able to repurpose that then into potentially the input material or into specialty chemicals or other applications. That is an emerging market. It has been in works for some time, but it's an advanced materials market, so it takes time to commercialize. But ultimately, the creation of these markets is an intersection of the technology, the growth of that technology, certain aspects of public policy as well. For example, in California with these thermoforms, where they have a high demand for them for agricultural products, they're entertaining a legislation now for a certain amount of post-consumer content in those thermoforms as well. So there is an intersection of several forces that can help develop those markets. And in some cases, there are some polymers that start driving their own market. As I'm sure Ali explained a bit more in depth about polypropylene. That polymer in particular has always been on the kind of this edge. It could be sorted. It's quite frequent. And now the polymer is becoming in high demand for its ability to be reused several times. The price is increasing. The material recovery facilities want to sort it. There's a consistent market downstream and a stable price. So market development is probably one of the most important aspects of recycling. For as much as we want to recover these materials, we do need a downstream buyer and a stable price.
You always need a buyer, right?
That's right.
Create the market. So to help create the sorting, the pulling this out of the stream, it's just, everybody just puts their recycling in the recycling bin and just assumes that it all gets recycled, but it's not the case. It's like there's a whole bunch of work that has to go into that. And I certainly appreciate what you guys are doing. And I'm just wondering, you guys have gone through a couple of rounds of financing. I looked online, get 77 million already. When are you guys going to do an IPO? Because I'm ready. I'm ready to invest. I know you're not the investor person to talk to, but What's the future, I guess, is what I'm getting at for you guys. Like, how exciting is it to work in this space?
Well, it's really exciting to be at AMP Robotics. It's also exciting to be around the innovation that's occurring in recycling, because it's not just us. There's a lot of activity around the sorting, around the packaging design, the collection, these markets. One thing I think AMP Robotics has done really well in the past several years is really shine a light on the innovation and the potential within recycling. And there's a lot of really smart, hardworking people in the industry that are really focused on different aspects of that value chain and reducing the inefficiencies, because recycling really does have the potential to be quite profitable industry for the recovery of these materials. AMP is growing quite rapidly. At this time last year, we had about 40 to 50 employees. Now we have about 140 employees. Whoa. And we've deployed several hundred robots around North America. We have a partner in Japan that distributes our robots for a different application. And we have staff in Europe now that's and deployed robots in Europe as well. So we have really we're still at the tip of the iceberg. There's a long ways to go, a lot of hard work still, but we are now really this transformation from that R&D company to a consistent, stable product that's in demand globally, and staffing and growing to meet that demand.
That's very exciting. You're at that stage where it might be hard to know everybody that's working at the company, right? The culture of the business is probably changing. It's a challenging but exciting stage. I've come to understand. It is,
but we have also a great group of people at the company who've been quite challenged with shelter at home orders in the pandemic, but have really helped foster a unique culture at the company. It's a lot of fun, keep people linked and together in a potentially virtual world for those of us who were virtual during that time. We had our first company gathering last week in over a year with our barbecue. So a lot of new faces, or faces that you've only seen on the screen.
Right. Rob, well, I wish you the best of luck. And I think, I'd love to have you back in a year. And let's just, I'd love to hear that you guys are at 300 employees now, and see where you guys are, about letting me know when you go for an IPO. This sounds really cool. I think anybody that's listening to the show, go onto AMP Robotics website and check out some of the videos that they have of the demonstrating of the mechanics. I don't know. I'm just so intrigued with computer vision and the actual applied, the sorting. What do you call those things, by the way? The things that sort of stick out and suck the thing out of the conveyor belt. What did you call those? The
end effector, or the gripper?
The gripper.
Yeah.
That combination is incredible. Rob, thank you so much. How should they reach anybody that's just listening? How should they get to you guys if they're interested in learning more?
Yep, amprobotics.com, and also AMP Robotics on Vimeo, where you can see cool robot videos instead of having to listen to me describe them.
Well, hey, Rob, thank you so much. Best of luck, and let's keep in touch, okay?
Thank you, Ernesto.
All right.
For more episodes of Through the Noise, go to throughthenoise.us.